The kernel is not aware of the existence of thread, that everything which is done by the thread, it is only take place into the user area. So all thread management is done by the application which is using by the thread library, and that threads is creating by the user. So everything regarding the management of thread is done by the application. Okay, so this thread is actually creating into the user area memory location, user area location. That is why it is called user level thread. And user performs over any applications, and application creates the threads. So the entire management done by the user through the application, and application will manage all the threads. So kernel never take care about these kind of threads, because this is not their own responsibility, because threads are not executing into the kernel area at the time, right? So threads switching does not require kernel mode privileges. That means no need to switch, because there is no such requirement of kernel to execute that user thread. Okay, as far as the scheduling is concerned, scheduling is also not performed by the kernel. Okay, because it is application specific, right? So user level threads implement in user level library rather than via system calls. So all threads will be take care through the user level libraries. So, and switching does not need to call operating systems and to cause interrupt to the kernel. Okay, we need not to call the kernel through the system calls, because all activities perform through the libraries which is already exist into the user level. In fact, the kernel know nothing about the user level thread. Okay, as I told you that the thread uh, is creating into the user area, right? The responsibility for execution of all the threads is for application, is of application. So kernel, it is not in picture for the execution of threads. User level thread is specific and manages them as if they were single threaded process, right? So let's define the user level thread. What is exactly the user level thread? The first term, which is very important, the kernel is not aware of the existence of thread. All thread management is done by the application by using thread library. Okay, thread switching does not require kernel mode privileges and also not required any such scheduling algorithms. Right. So user level thread implements in user level libraries rather than via system calls. So here thread switching does not need to call operating system, and so for to cause interrupt to the kernel, right? Let's have a look advantages of user level thread. Thread is not required because all the threads will complete their own execution into the user area. It does not require kernel area for completing our execution. So there are no such switching. Okay. Second advantage, choose the best algorithm. That means scheduling only performed by the application. Okay, it is also based on the specific application. So over the thread there are no such based algorithms, but the application can apply it through the specific algorithms. So scheduling can be application specific, we can say like that. Okay, so choose the based algorithms and it will be based on the application specific. Third advantage, only needs a thread library. So to perform the complete execution of thread, we just need the user level thread library. We does not require anything. We do not require anything, right? So only needs a thread library. Fourth, no operating system modification required. That means if a user level thread, as I told you, a user level thread does not require any modification to the operating system, even though we do not call to operating system for complete execution of our thread. Okay, so a user level thread packages can be implemented on an operating system that does not support the threads. Okay, that's why no operating system modification required. Okay, fifth is simple representation. Simple representation, it is very easy that each thread is represented simply by a PC, personal computer, right? Maybe it may be represented via a simple register, maybe it may be performed through the stack and a small control block. Okay, all stored in the user process address space, because threads in the lecture when we discussed about the process control block and thread scheduling over the thread, so I told you that threads does not engage any such kind of memory. It's only referred to the existing address which engaged by the process. Okay, so if process contain number of threads, so process have their own context, it contain the address space physically. Threads does not require any such physical space. It's only refer to the part of process, it's only refer to the instance of process. Okay, so the representation is very easy. Each thread is represented simply by a PC, program counter and a registers, stack or small control block, and all stored in the user process address space. Now sixth is simple management. Okay, simple management, that means this simply means that creating a thread, switching between threads and synchronization between threads can all be done without intervention of the kernel, right? So we need not to switching from user area to kernel area again and again. So that is the management of threads is very easy. especially if the user level threads, management of user level thread quite easy as compared to kernel level threads, because the code which is going to execute in the user area, it only completed their own execution through the system user level libraries. Okay, so if we do not require to call the operating system, we do not require to call a kernel area, so the management of his user level thread is very easy. Okay, and the last is fast and efficient. So thread switching is not much more expensive than a procedure call, right? This is very fast and efficient because thread switching is not much more expensive than a procedure call. Okay, to call a procedure, it will take a certain time or cost. If we measure the based upon the CPU performance, it may be generate some cost which may be expensive, but the thread switching, it is not. Okay, let's have some disadvantage also. So disadvantage of user level thread, first is most system calls are blocking and kernel blocks processes. What does it really mean? Most system calls are blocking and the kernel blocks processes. That means, so all the threads within the process will be blocked. A user level thread requires non-blocking system call, that is a multi-threaded kernel. Otherwise, entire process will blocked in the kernel. Even if there are runnable threads left in the processes, you can take an example. If one thread causes a page fault, the entire process gets blocked. This is very crucial disadvantage of the user level thread. If any thread which is not present into the primary memory, that means due to some thread, if there is any such page fault occurs, the process may be blocked. This is the first disadvantage. Second disadvantage is the kernel can only assign processes to processors. Two threads within the same process cannot run simultaneously on two different processors. So it is depending that kernel can only assign processes to the processors. Kernel can only assign processes to processors. This is again a disadvantage. Third is there is a lack of coordination between thread and operating system kernel. Right now, therefore, process as whole gets one time slice irrespective of whether process has one thread or 1000 threads within. Okay, so it is up to each thread to relinquish control to other thread. Right, so this is about the disadvantage of user level threads. Now next is the kernel level thread. Kernel level thread, that means user level threads required their own execution or complete their own execution. It required the system call, it requires the operating systems. right? So somehow we need to carry the context of user level thread into the kernel area, right? In this level, all thread management is done by the kernel. No thread library but an API, that means system calls, to the kernel thread facilities exist. The kernel maintains context information for the process and the threads. Switching between the threads requires the kernel scheduling is also performed on a thread basics. In this method, the kernel knows about and manages the threads. No runtime system is needed to this case, right? So instead of thread table in each process, the kernel has a thread table that keeps tracks of all the thread in the system. That is very important point. Kernel has a thread table that keeps track of all the threads in the system. So in addition, the kernel also maintains the traditional process table to keep track of processes. Okay, operating system kernel provides system call to create and manage threads. Okay, so let's define the kernel level thread. The first important things, kernel knows about and manages the threads. No runtime system is needed in this case. Okay, all threads management is done by kernel. No thread library but the API, which is system call, in our case system call to the kernel thread facility exists. Okay, now advantages of kernel level thread. The kernel can simultaneously schedule many threads of the same process on many processors. Blocking is done on a thread level. That means, so first advantage is the kernel can simultaneously schedule many thread of the same process on many processors. Blocking is done on a thread level. Okay, but in the first when we are discussing about the user level thread, user cannot simultaneously schedule number of processors, right? Because there is only single processor system and single threaded environment where user can create a single thread and use application only creates a single thread, right? Now here kernel can simultaneously schedule many threads of the same process. So if single process have multiple threads, then the management of all threads possible into the kernel level threads, because all the threads maintained or managed by the API system calls, which is called by the operating system, right? Advantage of two. Second advantage, the kernel routing routines can be multi-threaded, right? Advantage number 3, because kernel has full knowledge of all thread, scheduler may decide to give more time to a process having a large number of threads than process having a small number of threads. This is again advantage of thread. Because the kernel has full knowledge of all the threads, the scheduler may decide to give more time to a process having large number of threads than a process having small number of threads. Kernel level threads are especially good for application that frequently blocked. Okay, this is the fourth advantage. Kernel level thread are especially good for applications that frequently block. Okay, let's have a disadvantage. Also have a disadvantage of kernel level thread. The first is the thread switching within the same process involves the kernel. Okay, the switching of thread will be performed by the kernel. For example, if one has 2 mode switches per thread switch, this result is in a significant slowdown. Okay, so let's have a disadvantage first. Thread switching within the same process involves the kernel. Right, we can take an example like if one has 2 mode switches per thread switch, this result in a significant slowdown. Okay, the second is the kernel level threads are slow and inefficient because it's depend upon the number of mode, right? So if we have number of mode switches, the result and output or the throughput of kernel automatically slow down. So kernel level threads are slow and inefficient. For instance, threads operation are hundreds of times slower than that of user level threads. Okay, last disadvantage is since kernel must manage and schedule threads, as we already know, kernel must manage and schedule threads as well as processes also. It require a full thread control block for each thread to maintain information about thread. As a result, there is significant overhead and increases increased in kernel complexity. Okay, so since kernel must manage and schedule threads all as well as the processes, it required a full thread control block for each thread to maintain information about thread. As a result, there is a significant overhead and the increased in kernel complexity. Okay, so that was the disadvantage of kernel. So in this lecture we discussed what is user level thread, then user level thread, advantage of user level thread, then we will start the kernel level thread and finish our topic on advantage of kernel level thread, then disadvantage of kernel level thread. Thank you.